Hello students, welcome to Sri Jayendra's Ring Zone classes. I am your friend and mentor for coming classes with respect to physics. This is lecture number 15 of a unit Laws of Motion. In this session we are going to discuss about the previous year asked questions. It means you well understood that this is the last lecture of a unit Laws of Motion, as well as we are going to discuss only those questions which have been asked previously in certain competitive examinations. So if you have not revised it thoroughly from first lecture to the 14th lecture of laws of motion, please stop this video, go through your notes, go through the video lectures, but revise it. Once you revise it, reattempt this, and you will find that you can do many of the questions. Ideally you must be able to do approximately 70 to 80 percentage questions of this lecture. Is it clear? Is it? So let's begin then. Be ready with your pen and paper. You are going to do it with me. Yes. So be ready and all the best. Let's have a look. The question says it is that the maximum tension a rope can withstand is 60 kg weight. Look at this. They have given 60 kg weight. That means 60 multiplied by g. The ratio of the maximum acceleration with which two boys of masses 20 kg and 30 kg can climb up the rope at the same time. So what you are supposed to do is, let's suppose this is rope and here boy is there. He is moving in the upward direction. This is T, this is mg, and he is moving in the upward direction. That means this must be the acceleration. So this could be written as T minus mg is equals to ma, and that's why we can write it's a T is equals to m into bracket a plus g. Now it says that the maximum tension a rope can withstand is 60 kg weight. So T max, that is equals to 60 kg weight, which could be 60 into 10, which is equivalent to 600 Newton. So this is the T max. So what I can write is that 600 is equals to 20 into a1 plus 10. We don't know the acceleration of them, yes, but we know that it would be a plus g. So this is 600 is equals to 20 multiplied by a by 10, and from this I can have a1 is equals to 20. Same way, a second relation, 600 is equals to 30 into bracket a2 plus 10. If I solve this, I am having a second acceleration as 2 10. I need a ratio of this two. It's an even in a1 is to a2, which could be given as 2 is to 1. Got it? Yes. What was your answer? What was it? Is it same? Is it? Great. Let's have a look at this question. It says that a uniform chain of length L is lying on a horizontal table if the coefficient of friction between the chain and the tabletop is mu. So situation could be something like this. This is a horizontal chain of length L is, and if the this is horizontal chain of length L which is lying on the table. The coefficient of friction between the chain and the tabletop is mu. What is the maximum length of chain that can hang over the edge of the table without disturbing the rest of the chain on the table? Okay, great. So they want something like this, that a certain segment has been hanging. Let's suppose this hanging part is of L. So this resting part would be the L minus of L. Yes, because the total length of the channel is the total length of the chain is L. So now what I understand is that mg of L mg of L length should be equals to friction of L minus L length. If this two could be balance each other, this two could be balance each other, then there would be no relative motion. Yes. So mg of L part, how could I calculate? It's a total mass m, total length L, multiplied by, you have used, it's an L, multiplied by g. That should be equals to friction. For friction I need to write it is a mu s into n on the L minus L length. So let's have a look. It's m by L multiplied by L multiplied by g, that is equals to mu s into n. This is equals to mu s into mg. Now again I need to write it's a m by L into bracket L minus L multiplied by g. This was equals to m by L into g. So let's try to solve this. It's a m has gone, g has gone, yes, L has gone. So I have been remain with L is equals to mu s into bracket L minus L. So this mu s, what is the maximum length? Okay, length is required. So what is the, without disturbing the rest of the table, yes. So this L is equals to, this L is equals to mu s into bracket L minus L. So let's just solve this. It's a mu s into L minus of mu s into small l. It's an L plus mu s into L should be is equals to mu s into capital L. So L as a common, 1 plus mu s should be is equals to mu s into L. So L could be equals to mu s into L upon 1 plus mu s. This could be your final answer. What was yours? What was yours? What was it? Yes, what was it? Does it seem? Great. Ready for the next question? Are you ready? Let's have a look. Yes, it's a very good question. Read it very carefully because something is hiding over it. It says that two fixed frictionless inclined plane making an angle of 30 degree and 60 degree with the vertical as shown in the figure. Two blocks A and B are placed on the two planes, and what is the relative vertical acceleration of A with respect to B? What they want a relative vertical accelerations of A with respect to B. So this is what they required. Now how can you do this? How can you do this? So what we need to understood is that this is the g sine theta, or I should say it's a g sine theta 1. This is the g sine theta 2. Yes, this is their acceleration, g sine theta 1, g sine theta 2. But what they want, it's they want a relative vertical acceleration. So when I say it's a vertical acceleration, if this angle is theta, if this angle is theta, this must be the theta. Yes. So if this angle is theta, this must be the theta. So if this is g sine theta, this is g sine theta into cos theta. Let's say, suppose this is I write down this as a a1, I write down this as an a2, then I should write this is a1, this is a1 cos theta 1 or cos theta, and this is a1 sine theta. I hope you understand. This is 30. So if this is theta, even this could be written as theta 2. This is a2 cos theta 2, and this could be written as a2 sine theta 2. I hope this is clear. So we can have relative acceleration, that a relative could be equals to a1 sine theta 1 minus a2 sine theta 2. So now while I write a1 sine theta 1, it is the g sine theta 1 multiplied by sine theta 1 minus this is g sine theta 2 multiplied by sine theta 2. So this is g into bracket sine square theta 1 minus of g sine square theta 2. So this is equals to g into bracket, this is first angle, it is of 60 degree, so sine square 60 degree minus it's a sine square 30 degree. While I write sine square 60, sine 60 it's a root 3 by 2. If I square it it's a 3 by 4 minus of sine square 30 it's a 1 by 4. So this is equals to g into 3 by 4 minus 1 by 4, it's a 2 by 4, which is g by 2. While I say g by 2 it's a 9.8 by 2, so that would be 4.9 in vertical direction, 4.9 in vertical direction. Yes, this could be the answer. Yes, I have seen many of the students that commit a mistake that they understood only the relative accelerations. So they are going to do this g sine theta minus g sine theta and they are going trying to find out the answer. Please do not commit this mistake. They have clearly mentioned that what is the relative vertical acceleration. So when they mention it's a vertical acceleration, you need to go for it. I hope this is clear. Is it? Is it? Are you sure? Great. A very good question. Let's work for the next question. Let's have a look. What does it says? It says that a particle of mass 4m explodes into three pieces of masses m is to m is to m. It's mm to m. Great. The equal masses move along x-axis and y-axis with the velocity of 4 meter per second and 6 meter per second. So situation is something like this. It was the bomb having a mass of let's say 4m. As it is going to be blast. The this is the mass m is moving in x direction with velocity of 4 meter per second. This another mass is moving in this direction, again a mass having a its mass same and velocity it's a 6 meter per second in the y direction. The magnitude of the velocity of the heavier mass, that means I'm required the magnitude of this. As we know that when this particle explodes, momentum of the system momentum of the system will be conserved. So as I know that momentum of the system is going to conserved, and once I know that momentum of the system is being conserved, what I can write is initial momentum of the system is equals to final momentum of the system. One of the particle has gone in this direction and it is having a velocity of 4. Another particle has moved in this direction, it is having a velocity of 6. So initially momentum was 0, so even on the finally it should be in 0. So what I can have is that we can write like this, it's a 4 into m I cap plus 6 into m j cap plus 2m into v, because we don't know the direction. Yes, so this could be written as 2m into v should be equals to minus of 4m I cap plus 6m j cap. So this v could be written as minus of, this is to be divided, it's a 2mi, it's a 2i, sorry, it's a 2i plus 3j. If I want the magnitude, it's a mode of v should be equals to root of, it's a root of 4 plus 9, that should be equals to root of 13 meter per second. I hope this is clear. What was your answer? What was your answer? Is it same? Is it? So will you be capable enough to do this? Are you sure? Are you sure? Great. let's work for the next question. It says that a boy of mass 50 kg is standing on a weighing machine placed on the floor of a lift. Okay, so the situation is something like this. He is standing at rest. The machine reads his weight in Newton. Okay, what is the reading of the machine if the lift is moving upward and downward? Moving upward with a uniform speed of 10 meter per second. Okay, so initially this is at rest. Initially this is at rest. His weight, sorry, his mass is 50 kg. So this is 50 into g, and this would be the normal. So machine is going to read n equals to 50 into g, which is a 9.8, which should be 490 Newton. Now the question says that what is the reading of the machine if the lift is moving upward with a uniform speed? Look at this. This word is very important. Uniform speed of 10 meter per second. So what we understood is that according to the Newton's first law, no force is required to move an object with uniform speed. Yes, that means if an object is in motion, then you do not need to pull, or do not need to provide any extra force so that it can move with the same speed. So here, even and this plane, even this plane is moving with 10 meter per second. The reading would be the same. It's a 490 Newton. I hope this is clear. Is it clear? Is it? Great. But if I add something to this question, that let's suppose after this this person is moving upward and with a speed with an acceleration of 2 meter per second square, sorry, and now it is going to move the in the downward direction with again same acceleration 2 meter per second square. Now I want that what would be the normal one, what would be the normal 2. While I say normal, we are taking the readings of the weighing machine. Normal always shows the reading of the weighing machine. If it is at rest, it is the true weight. If it is moving in upward direction or downward direction with certain accelerations, that means it is just the apparent weight. I hope you understand. Yes. So what could be done? I am doing one of them, and rest of second one will be on yours. So let's suppose this is normal. This is mg, and it is moving in the upward direction. So this would be n minus of mg is equals to ma. I have written it as n minus mg is equals to ma because I know that it is moving in the upward direction. And if it is moving in the upward direction, a force which is acting on the upward direction must be higher. So this is n minus mg is equals to ma. Same way for this could be written as this is n, this is mg. So as this is moving in the downward direction, and as it is moving in the downward direction, this could be written as mg minus n should be equals to ma. Now let's just this a1 a2, let's suppose this could be n1 n2. Let's just put the value and get the answers of the n1 and n2. Is it clear? Is it? Great. Let's look at this question and do it quickly. It says that the object at rest suddenly explodes into three parts with mass ratio of 2 is to 1 is to 1. The parts of equal masses move at right angles to each other with equal speeds v. The speed of the third part after the explosion. Yes, we have did it. Just the same question. It was m is to m is to m. Yes, m is to m is to 2m. So this is try yourself. You can do it. Attempt it on your own. Let's work for the next question. Yes, it says that starting from the wrist, the time taken by a body sliding down on a rough inclined plane at 45 degree with the horizontal is twice the time taken to travel on a smooth plane of same inclination and the same distance. Then the coefficient of kinetic friction will be okay. So the situation is one of the plank is smooth. This angle is 45 degree. This is the block, but this plank is having friction and it is going to travel from top to bottom, and let's say it will take a time t1. This is h, this is x. They have mentioned that they travel same distance, so their x must be equal. So this is the plank with the friction. Some other plank is there, some other plank is there. Let's say something like this. It is a same plank dimension wise. This is h and block is here, then it is going to move towards the bottom, and if this is x, this must be the x. Now this is time t2. I hope this is clear. And they have mentioned that a body sliding down on a rough inclined plate with the horizontal is twice the time taken to travel on a smooth plane. So one more data is given, which is equals to t1 equals to 2t2. So this is all they have given. What I need to find it out, I need to find it out mu. I required a coefficient of kinetic friction. So how will you do this? How will you do this? So if I write the acceleration of this, let's write it as an a1, and let's write it over this, it's an a2. I know that we have done the previous questions as well, that this a1 should be equals to g sine theta, and this a2 should be equals to g sine theta minus of mu g cos theta. Sorry, first one is with friction, so this is equals to a1 is equals to g sine theta minus mu g cos theta, and a2 should be equals to g sine theta, because a1 is of with friction, a2 is of without friction. Now let's just do it. It is the same case. It's an x is equals to half at square. It's a half multiplied by, put up the value of a1. This is equals to g sine theta minus of mu g cos theta multiplied by t1 square. Put up the value of x2. It's a half into a2 into t2 square. That should be equals to half into a2, which is equals to g sine theta multiplied by t2 square. So this is t1 square, this is t2 square, this x1 and x2 is given. This x1 and x2 is given. Now what should we do? We know that t1 is to t1 is to t2 is given, as well as they given that the distances are same. If distances are same, x1 is to x2, this is equals to half multiplied by g sine theta minus mu g cos theta into t1 square. That should be equals to half into g sine theta into t2 square. I hope this is clear. So this half and this half has gone. Now I have been left with the, let's take a ratio of that t1 square divided by t2 square. This is equals to g sine theta divide by g sine theta minus of mu g cos theta. Now I have been given that t1 by t2 is equals to 2. That means t1 square divide by t2 square, that should be 4. t1 square by t2 square is equals to 4. So this is equals to 4 is equals to g sine theta upon g sine theta minus of mu g cos theta. So that should be written as 4g sine theta minus of 4 mu g cos theta should be equals to g sine theta. So this is 4g sine theta minus g sine theta. This is equals to 3g sine theta. That should be equals to 4 mu g cos theta. This g and this g has gone. So sine theta by cos theta, it's a tan theta, or I should say it should be mu should be equals to 3 by 4 into sine theta by cos theta, it's a tan theta. They have given theta as a 45, so it's a 3 by 4 into tan 45 degree. So this is 3 by 4. I hope this is clear. Is it clear? Is it? Are you sure? What was your answer? Was it same? Was it? Great. Let's look at next question. Go through the data. It says that a rifle of 20 kg mass can fire 4 bullets per second, and the mass of each bullet is 35 into 10 to the power minus of 3 kg, and its final velocity is 400 meter per second. Then what force must be applied on the rifle so that it does not move backwards while firing the bullets? Yes, we understood that when we fire the bullets from a gun, it will recoil. While I say recoil, that means if bullets are moving in the forward direction, then the gun will be moving in the backward direction. So they want the force which should be or which could be applied on a rifle so that this rifle does not move backward. So how will you do this? How can be done? It says that it fires n is equals to 4 bullets per second. Yes, mass of the bullet is given, it's a 35 into 10 to the power minus of 3 kg. Final velocity v is given, it's a 400 meter per second. So while I calculate, I must understand that F is equals to nmv divide by t. While I can replace n by t as a small n, it's a number of bullets per second. This is nmv. So this is the force that is required. So if I put up the value, it's a 4 bullets. Mass 35 into 10 to the power minus of 3 multiplied by 400. It's a 4 into 10 to the power 2. So this is equals to 35 into 4, it's a 140. 35 fours are, yes, it's a 140, and 14 fours are 56. It's a 14 fours are 56 into 10 to the power minus 3. So this is 35 fours are 140 into 4, it's a 560 into 10 into 10 to the power 2 into 10 to the power minus of 3. So this is 10 to the power 3, this is 10 to the power 3, which is going to cancel out each other. This is just the force. If I go with the direction, then it must be applied in the opposite direction. It must be applied in the backward direction. I hope this is clear. Is it clear? Is it? What was your answer? What was your answer? Was it the same? Was it? Are you sure? Can you do this? Great. Let's work for the next question. What does it say? Yes, it says that again the concept of apparent weight. It says that the apparent weight of a person inside a lift is W1 when lift moves up with certain acceleration. Great. So situation is something like this. This lift is moving in the upward direction A1, and In this situation, it measures the apparent weight as a W1. Now, and is W2 when lift moves down with same acceleration. Okay, acceleration would be same, so no need to write A1, A2. But now it is moving in the downward direction with acceleration A, and it rates its weight as W2. This is the second case. The weight of the person when lift moves with constant speed. Yes. So when lift moves with the constant speed, let's say this is the W3, when maybe it is going in upward direction or maybe it is going in downward direction, doesn't make any difference to it. So let's just find it out that which of the forces are acting. This is normal, this is mg, this is mg, this is normal, again this is normal, this is mg. I hope this is clear. Now in the first case, lift is moving in the upward direction, so which force will be bigger? Which one? Which one? Yes, yes, we can have it's an n minus mg should be equals to ma. As we have discussed in the previous slides that normal is giving the reading of the weighing machine, so this is w1 minus of mg is equals to m into a. This is my first relation. On the second relation, let's have a look that it is moving in the downward direction, and as it is moving in the downward direction, I can write like this: it's an mg minus of w2 should be equals to m into a. This is relation number 2. Yes, so let's just add it. If we are going to add this, we can have that this plus mg and minus of mg, this plus mg minus mg could be cancelled out, and this is weight 1 minus of weight 2. This is, yes, this is weight 1 minus of weight 2 should be equals to ma plus ma, that is equals to 2 into ma. I hope this is clear. Is it clear? Is it? Great. So now this is the a could be written as weight 1 minus weight 2 divided by 2. Is it clear? Great. So now after doing this, what you can do is put up the value of the acceleration in any one of the format. It's a, whether it is in a, whether it is in first relation or whether it is in second relation, and try to get it done. Try to get it done for W3. I hope this is clear. Is it clear? Is it? Great. Let's have a look at this question. What does it say? It says that a block of mass 2 kg is placed on the surface of a trolley of mass 20 kg, which is on a smooth surface. Okay. The coefficient of friction between the block and the surface of the trolley is 0.25, something like this. That here probably the block has been put, and this is a friction over is there. Its mu is 0.25. If a horizontal force of 2 newton, if a horizontal force of 2 newton acts on the block, this is, then the acceleration of the system in meter per second is, so a mass of the block, it's a 2 kg. So let's just find it out, the maximum friction that is acting on this block. That could be f limiting, which is mu s into m into g. This is 0.25 multiplied by 2 multiplied by 10, and when I say this is 0.25 into 2 into 10, this came to a 5 newton. Now I have applied a horizontal force of 2 newton. That means my applying force is less than the limiting friction. That means a friction at this point of time is just the 2 newton. One more thing, and very important thing, is that if limiting friction is 5 newton, you are applying force of just the 2 newton. That means acceleration of the complete system would be the same. That means this trolley as a first object and this block as a second object will be moving with same acceleration. So now a force applied is 2. Total mass of the system, it's a 2 kg of block and 20 kg of trolley. It's a 2 by 22, which could be a 1 by 11, and that is 0.09. This would be the answer. So you always need to check whether in this system there is a relative acceleration or not. If not, then this both the block, or I could say this both the masses would be moving with same acceleration. I hope this is clear. Great. Let's work for the next question. It says that a man slides down a telegraphic pole with an acceleration equal to one fourth of the acceleration due to gravity. Great. The frictional force between the man and pole is equals to, so something like this, that this is the man and it is moving downward. As it is moving in the downward direction, this is mg, this is mg. This could be written as the friction, and as it is moving in the downward direction, this is a. Now what should I do? What should I write? I should write it's an mg minus f should be equals to mass into acceleration. They have given something for acceleration, with an acceleration equal to one fourth of the acceleration due to gravity. So they have given this, it's an a is equals to g by 4. So this is equals to mg minus m into a, while a would be the g by 4. This is equals to friction. And if I write this as a friction, this is mg minus mg by 4. So this friction should be equals to 3 by 4 mg. For mg I can write the weight, it's a 3 by 4 into weight. This is friction. Is it clear? Is it? Are you sure? Are you? Got it? Yes, easy question. Let's have a look to the next question. It says that it says that a block of wood resting on an inclined plane of angle 30 degree just starts moving down. If the coefficient of friction is zero point 0.2, the coefficient of friction is zero point 0.2, its velocity in meter per second after 5 seconds. Okay, great. So the situation is something like this, that let's assume this is the wedge, this is theta, which is equals to 30 degree, and it is resting on an inclined plane. It just starts moving down, that means initial velocity is 0. If the coefficient of friction, that means this wedge is having a friction. So if I write it's a g sine theta in the forward direction, I should write it's a mu g cos theta in the backward direction. So acceleration, and it is accelerating in the downward side, that means it is equals to g sine theta minus of mu g cos theta. Final velocity is required, so this is equals to v is equals to u plus at. This is 0. A is equals to g sine theta minus of mu g cos theta multiplied by time t, that means they want after 5 seconds. This is the velocity, so just put up the value and get it done. It's a g, that is 10 into sine 30 minus of mu, this is 2 by 10 into 10 into cos theta, it's a root 3 by 2 into 5. So by solving this, you are having this, and that is your answer. That's it, you did it. Is it clear? Is it clear? Any doubts, any issue? No? Great. So ready for the next question? Do it quickly. Let's quick make it fast. It says that consider a car moving on a straight road with a speed of 100 meter per second. The distance at which car can be stopped. They have given the mu k, coefficient of kinetic friction, as well as they have given the g. So how can you do this? How can you do this? What I understand from this is that, let's suppose car is moving in the forward direction and the friction is acting in the downward direction. Initially it is having a speed of 100 meter per second, and it is going to be stopped by after traveling certain distance. Let's suppose from here its velocity would be 0, and this distance is, let's say, x. So what I can write is that v square minus u square, that is equals to 2 into a into x. This is 0 minus of u square, it's 100 square. This is equals to 2 into a would be equals to minus of mu g into x. So this is equals to minus of 100 square, this is equals to 2, or say 2 minus of mu is the 0.5, it's a 5 by 10 multiplied by 10 into x distance that is required. This is gone, this is on, it's 100 square, it's 100 square, and this is 10. So this is 10 into 10 to the power 3 equals to 10 into x. This is gone, and x equals to 1000 or 10 to the power 3 meter. I hope it is clear. It is? Yes, very easy. So shall I add something to this question? Shall I? Let's find it out. Find out time required to stop the car in previous question. So they have in the previous question they have been finding out that what distance will it travel before it is coming to rest. Now in this question, what I want that find out the time which it will take to stop. So what all things we have been provided is the final velocity is 0, initial velocity u, that is equals to 100 meter per second. I have been provided with mu k, which is equals to 0.5. So what I need to do is, it's a v minus u, that should be is equals to minus of a into t, minus because it's resistive. This is 0, this is minus of 100, this is equals to minus of a. A could be written as mu into g, this is 5 by 10 into 10 multiplied by t. This 10 can gone, this has cancelled, and this t should be equals to 100 by 5, which should be equals to 20 seconds. Got it? This time this is equals to 100 by 5, and when I say 100 by 5, it is equals to 20 seconds. I hope this is clear. Is it clear? Is it? Are you sure? Are you? Great. Let's move to the next question. Make it fast. Let's have a look. It says that the minimum force required to move a body up an inclined plane is three times the minimum force required to prevent it from sliding down the plane. So if the coefficient of friction between the body and the inclined plane, the coefficient of friction between the body and the inclined plane is 1 by 2 root 3, the angle of the inclined plane is okay. So let's try to make a sketch of it. It's a theta, and let's say this is the block M. First, what they want that the minimum force required to move a body up an inclined plane. That means they were talking about this force. This is, let's write it down as an F1. Yes, it is the minimum force required to move a body up an inclined plane. So when I say it's an F1, uh, the forces that are acting in the downward directions are as it is moving in the upward direction, that should be the mg sine theta in downward direction, as well as friction is acting on the downward direction. Now this is three times the force required to prevent it from the sliding down the plane. So if I understood this very carefully, then it means this block this block is moving in the downward direction, and as it is moving in the downward direction, I must understand that friction should be acting on this direction. Friction should be acting in this direction. I need to apply a force F2 over here, but mg sin theta again acting on this direction. Yes, so they mentioned that should be F1 should be equals to 3F2. I hope this is clear. Now, according to the diagram, I can have F1 which is equals to mg into bracket sine theta plus mu cos theta, and F2 is equals to F2 plus F. F2 plus F is equals to mg sin theta. So F2 is equals to mg sin theta minus of friction. It's a mu mg cos theta. So we have this relation. It says F1 is equals to 3F2. This mg and mg could be cancelled out. Yes. So I have been left with the here on the this side sin theta plus mu cos theta, and here it's a 3 sin theta minus 3 mu cos theta. It's a 4 mu cos theta is equals to 2 sin theta. So this is equals to this is 4, this is 2, so this would be the 2. So mu is equals to 10 theta. It's a sin theta by cos theta, which is a 10 theta. So this mu is equals to 10 theta by 2. Now they have provided the value of a mu, which is 1 by 2 root 3. If I put up the value, it's a 10 theta. This 2 has gone, so 10 theta would be 1 by root 3, and while I say 1 by root 3, it is theta, which is equals to 30 degree. So is it clear? Is it? Are you sure? Are you? Great. So can you do this? Yes, it's a very good question. Only the thing is that they have play with the words when they were talking like this. Yes, this is we need to deal it. Yes, and once we are able to deal this kind of questions in which data has not been given but only the description is given, then it is very very essential to understand the descriptions, that what they are want. Yes, because once if they have been provided with this data, let's suppose if they have provided this diagram and they ask you that find out the theta, then it would be a very much easier. Yes, this is much easier. Only the difficulty is that we could not understand that how to make a free body diagram of this, so that their condition can be satisfied. So that is typical. I hope this is clear. Yes, you would be having a mastery over it once you have been gone through so many questions and so many trial and error approach, and so many errors would be there, so many difficulties would be there, but at the end of the day you will be able to solve this kind of questions. I hope this is clear. So well done, you did a great job. Let's move to the next question. It says that the upper half of an inclined plane with inclination phi is perfectly smooth, while the lower half is rough. And it says that a body starting from wrist at the top will again come to rest at the bottom if the coefficient of friction for the lower half is given by. Now look at this, we were talking about this only, that they are going to only describe the situation, they are not going to have any diagram, anything. So what I need to do is, let's make this is my wage, this is angle theta, and they have mentioned that this could be divided into two segments. Let's suppose this is first segment and this would be the second segment. A block is there which is initially at rest, and when it reaches to here, it is again having a final velocity as a 0. First half is smooth, that means having no friction, while the lower half is rough, so this is having a friction. So now what I can do, I understood that I am having a velocity, I am having a distance. So let's suppose when this block reaches over here, write it as a v1, and we will see initially only this journey. This is v1 square minus of u square is equals to 2 into a, which is equals to g sine theta because it's a rough pitch, into x. So this is v1 square, u is 0, this is equals to 2 into g into sine theta into x. This is relation number 1. Now for the second half, this is v1, this is v is equals to 0. So this is final velocity, this is initial velocity for the second half. So what I can write, it's a v square minus of u square is equals to 2 into bracket g sine theta minus of mu g cos theta into x. I hope this is clear. So this final, it's a 0 minus initial, it's a v1 square should be equals to minus of 2 into bracket g sine theta minus of mu g cos theta into x. This is relation number 2. This 2 could be done. Yes. So as according to the first relation, we were having v1 square, it's a 2g sine theta into x, and now I am having it's a 2g sine theta minus 2 mu g cos theta multiplied by x. I hope this is clear. Is it clear? Is it? Are you sure? So now could you do this? Could you? Will you be capable to do this? Are you sure? So this should be the v1 square, and let's just make it clear that this is 0 minus of v1 square, and this is equals to plus 2 into g sine theta minus mu g cos theta into x. So let's just compare this. It's a minus of 2 into g into sine theta into x. This is equals to 2 into bracket g sine theta minus of mu g cos theta into x. This x and 2, this could gone. So this is minus g sine theta. If I move it on this side, it's a minus of 2 into g into sine theta should be equals to minus of mu into g into cos theta. This minus minus plus, this gg could gone, and mu should be equals to 2 into sine theta by cos theta. This is tan theta. I hope this is clear. Is it? Is it clear? So can you do this? Can you? Are you sure? Can it be done? Can it be? Great. Let's work for the next question. Do it quickly. Look at the question. What does it say? It says that a block is kept on a frictionless, oh, no friction is there, inclined surface with angle of inclination which is alpha. The incline is given an acceleration a to keep the block stationary. Then a is equals to, yes, we have did this. That this a should be equals to g tan alpha. If you are not knowing this, then please revise the lecture of a pseudo force. We have did this question in the lecture of pseudo force. So let's discuss all the questions that has been related with this. That this acceleration should be equals to g tan alpha. The force that I need to act, on this, it's a m plus m into a. So in reality, it's an m plus m multiplied by g tan alpha. I hope this is clear. One more thing. Reaction force between block m and wedge m is, let's say r, it's an mg by cos theta. So this is r is equals to mg, sorry, this is mg by cos theta. So you need to remember these three things. Yes, that what we are supposed to do is we are just pulling it, we are just pulling it, we are just pushing it, sorry, we are just pushing it with certain force F, so that there could not be any relative motion of the block small m on the wedge having a mass capital M. So for this you need to apply a force that is of F is equals to m plus m into A, and that A would be equals to G tan alpha, and the reaction force between the block and wedge, it is equals to the M, and reaction force could be given as this reaction force could be given as mg by cos theta. Do not make a mistake to make it mg cos theta. Yes, let's have a look to the next question. Let's do it quickly. It says that a block is at rest on a rough inclined plane making an angle 30 degree with the horizontal if the coefficient of friction between the block and the plane is 0.8. If the frictional force on the block is 10 Newton, the mass of the block is okay. So what you understand is that, let's suppose this is the situation where it is making an angle 30 degree. We don't know the mass of an object. That is what we are working for. We know the coefficient of static friction, that this is the coefficient of static friction, this is mu equals to zero point 0.8. Okay, now if the frictional force on the block is 10 Newton, let's suppose friction is acting over here. Yes, the mass of the block is, we required the mass of the block. So what I understood is that one of the forces acting over here, and that would be equals to mg sine theta. So it says that a block is at rest. When I say a block is at rest, that means this friction must balances this mg sine theta. Yes, this friction should be equals to mg sine theta, and when I say friction is equals to mg sine theta, it is the 10 Newton. The mass it's required, g is the 10, sine theta it's a sine 30, which is equals to half. So this has gone, and mass would be the 2 kg. I hope this is clear. Is it? Is it clear? Are you sure? Can you do this? Will you be? Will you be able to do this? Are you sure? Are you? Great. So let's work for the next question. Do it quickly. Well done. It says that the coefficient of static friction between the block A of mass 2 kg and the table as shown in the figure is 0.2. Okay, this is the friction which is equals to 0.2. What would be the maximum value of the mass of block B so that the two blocks do not move? Okay, so what I understood is that if this are not going to move, that means mg is acting over here and friction is acting over here. Yes, so if friction on this block is equals to the mg of this block, this are not going to move. So let's just equate them. So it's a mass of B into G, that should be is equals to friction on the block A. Friction on the block A could be calculated as mu into ma into G. This is equals to mb into G. This G could gone. Mass of B that is required. Mu, it's a point 0.2. It's a 2 by 10. And mass of A, it's a 2 again. It's a 4 by 10, which should be a 0.4 kg. I hope this is clear. Got it? Got it? Are you sure? Great. Let's work for the next question. It says that a marble block of mass 2 kg lying on ice with given a velocity of 6 meter per second is stopped by friction in 10 seconds. Okay. Then the coefficient of friction. Now, how could you do this? How will you do this? So the situation is that this is, let's suppose this is the ice cube or ice plate, and it's let's suppose this is the marble stone. It is moving over here. That means it is gliding over there. and it is initially having a speed of 6 meter per second, and it finally comes to rest. So what is think what can be done? It's a v minus u is equals to 80. So the final velocity is going to be 0. Initial velocity, which is equals to 6. A could be written as mu into g into time t. So this minus 6 is equals to mu, that is what I'm working for, into minus of mu into g, it's a 10 into time, it's again 10 seconds. So if I solve this, it's a minus minus plus, so mu is equals to 6 by 10 times 100. This is equals to 0.06. This is mu. I hope this is clear. So these are very easy questions. These are very easy questions that have been asked in the previous years. Yes, only the thing is you need to do this within a time frame. You need to do within a time frame. That is only the requirement. Let's look at the very good question. It says that a block of mass root 3 kg is kept on a frictional surface with mu. It is given 1 by 2 root 3. The minimum force to be applied as shown to move the block. Yes, this is tricky. How will you do this? Take a time of 10 seconds and let me know how should we do this. How could I do this? Have you did it? Can it be? No? Let me help you. So first, make every forces that are acting on the system that this is F. So this must be the F cos theta. And if it is F cos theta, this must be the F sin theta. This must be the mg. And from this block, from this table, there will be a normal force acting on the table, acting on the block, sorry. So it's a normal force. And if it is going to move in the positive x direction, if it is going to be moved in the positive x direction, so that the friction could be there in the negative x direction. So this block can start moving if F cos theta is equals to friction. If, because this is minimum force required, this is starts moving if F cos theta is equals to F. Now what is F? So we understood that it is mu s into n. What is n? So do not make a mistake over here that n is equals to mg. No, it is not. So n is equals to look at this diagram, this n is acting in the upward direction, mg is acting in the downward direction, even F sin theta is acting in the downward direction. So what I need to do is that I need to write n is equals to mg plus F sin theta. So if F cos theta is equals to mu s into bracket mg plus F sin theta, then the block will move, and this is the minimum horizontal, or this is the minimum force required to be applied on the block. So this is F multiplied by cos theta, it's cos 60 degree, which should be an half, should be equals to mu s, should be equals to mu, it's a 1 by 2 root 3 into mg, m is the root 3, this is root 3 into 10 plus F, that is what I'm working for, and sine 60, this is root 3 by 2. I hope this is clear. So if you try to solve this, it's a root 3 root 3 root 3 has gone, it's a 2, and this 2 has gone. So this f is equals to, here the term that remain is 10f plus 1 by 2. I hope this is clear. Is it clear? Is it clear? Yes. So from this, you need to solve this. From this, I hope you can. You are sorry. This is 10 plus. I made a mistake. It's f is equals to this is equals to the 10 plus f by 2. Yes. So this is required. From this, it's an f by 2 is equals to 10 and f is equals to 20 Newton. I hope this is clear. Yes. So a location where student is just going to made a mistake is that this n should be equals to mg plus f sine theta. This is very very important over here. Yes, I'm not telling you to remember it, but just have a look on this that every time n is not equals to mg when it's an horizontal surface. Yes, you always be very very careful in this kind of questions because we generally made a mistake by taking n is equals to mg and then the complete numerical will be landed on the wrong answer. I hope this is clear. Is it clear? Is it? Are you sure? Great. So, ready for the next question? Are you ready? Let's have a look. What does it say? It says that a light string passes over a smooth light pulley, connects two blocks of mass m1 and m2. Okay, vertically. If the acceleration of the system is g by n, then the ratio of the masses. Great. Let's have a look. Let's suppose this is m1 and this is m2, and they says that acceleration could be written as, let's suppose it's an m1 minus m2 divide by m1 plus m2 into g, and the acceleration which is given is it's a g by 8. So this is g by 8, that should be equals to m1 minus m2 divided by m1 plus m2 into g. This g has gone, and I will be left with m1 plus m2 would be equals to 8m1 minus 8m2. I hope this is clear. So this is equals to m2 plus 8m2, it's a 9m2, which should be equals to 8m1 minus m1, it's a 7m1. So that should be m1 is to m2, that is equals to 7 is to 9, or m2 is to m1, which is 9 is to 7. So this would be the answer. Very easy. Yes, have you got this? Have you? Great. So ready for the next question? Are you? Let's have a look. It says that three identical blocks of masses m equals to 2 kg are drawn by a force of F which is equals to 10.2 Newton with an acceleration of 0.6 meter per second square on a frictionless great surface. Then what is the tension? What is the tension in the string between the blocks B and C? That means you require tension over here. So how could you do this? You know that the force applied is 10.2 Newton. The force applied is 10.2 Newton. Three identical blocks of mass 2 kg. So this is 2, this is 2, this is 2. Even they have provided the acceleration. That acceleration is equals to 0.6 meter per second square. So let's have a free body diagram of C. Only one of the forces acting, that's I have denoted as TB, and this could written as TB is equals to mass into acceleration. This mass is the 2, acceleration it is equals to the with an the acceleration it is of 0.6. Yes, the acceleration this is equals to 0.6. So that should be 2 into 0.6, 2 into 0.6, which is equals to 1.2 Newton. I hope this is clear. Is it clear? Is it? Are you sure? So what they want? What they want, the tension force in the string between the blocks B and the C. Is it clear? Is it? Great. Let's look at this question. The question says that a bullet of mass 25 gram moving with a velocity of 200 meter per second is stopped within 5 centimeter of a target. The average resistance offered by the target. Okay, this is what we have required. So initial velocity of the bullet is given, which is 200 meter per second, and it has traveled a distance of 5 centimeter, but as it is in centimeter, that needs to be converted, so I should write it's a 5 by 100 meter. Now what could I do? It's a v square minus of u square, that could be written as 2 into a into x. They said it has been stopped, so this final velocity is 0, this initial velocity, this is 200 square, that should be is equals to 2, that should be is equals to 2 multiplied by a multiplied by distance. The distance is 5, it's a 5 divided by 100. Again this should be a minus of a, because this is retarding force. So this is minus of 2 square, it's a 4 into 10 to the power 4. This is equals to minus of 2 into a into 5 divided by 100. So this minus minus plus, this is 4 into 10 to the power 4, that should be equals to 2 5s are 10 by 100 multiplied by a. So this could be written as acceleration should be is equals to 4 into 10 to the power 4 multiplied by 10, that should be is equals to 4 into 10 to the power 5. The force can calculated as F is equals to ma. This mass is of 25 gram, so this is equals to 25 divided by gram, it's 1000 multiplied by 4 into 10 square into 10 to the power 3. This has gone, this has gone, so this is 25 4s are 100 multiplied by 10 to the power 2, so that could be written as 10 into 10 to the power 3, which could be a 10 kilonewton. I hope this is answer and you got the same. Do you have the same answer? Do you? Great. Let's work for the next question. It says that a body of mass m collides against a wall with a velocity v and rebounds with the same velocity. What do you need to find out? You need to find out the change in momentum of the wall. How should I do this? So let's have a wall, and this is a body, this is having mass m, this is going in this direction, it is colliding with the wall with the speed v, and it is going to rebound. As it is going to rebound on the same path, I am just drawing it on the downward direction, so that you will have a feel that this is the incoming, this is the outgoing, something like that. Yes. So how should I do this? So first I need to write initial momentum, but while writing a momentum, I must understood that this is the vector quantity, and when it is a vector quantity, we must respect its magnitude as well as direction. So this is m into v into I cap. The final momentum, the velocity would be the same, only the direction is changing. So I should write it's an m into v into I cap, but this is in minus because this is minus I cap. So delta p, or I should say change in momentum, this is final momentum minus of initial momentum, that should be minus of mv I cap, minus of mv I cap, that should be is equals to minus of 2 mv I cap. If I want the magnitude only, if I want that magnitude only, that is delta p, that should be is equals to 2 mv in negative. I hope this is clear. Is it clear? Is it? Did you got the same answer? Do you? Great. Shall I add something to this question? That means modify something. Let's suppose this is wall, this is ball. If it is going to hit the wall in this direction, and this is making an angle theta with the horizontal, this is velocity v, and it is rebounding with the same velocity, again this angle is theta. Yes, find out change in momentum. Yes, this is the first case, and in the other case the situation is something like this. This is the wall, this is the ball, this is going to hit this, but this time it is making an angle theta with the vertical. This is kept as an horizontal, and this is the velocity v, this is the velocity v, again this is the angle theta. I hope this is clear. This is mass m, this is mass m. Does it clear? Does it does it clear? Great. So will you be capable enough to do this? Will you? Can you do this? Great. So are you ready for the next question? Are you? Let's have a look. It says that the next question says that the horizontal acceleration that should be given to a smooth inclined plane, smooth, not having any friction, smooth inclined plane of angle sine inverse of 1 by L, that means theta is equals to sine inverse of 1 by L. So that could be written as sine theta is equals to 1 by L. Okay, to keep an object stationary on the plane relative to the inclined plane. So have you remember this? Even we have discussed the same question in this class, as well as when we were discussing the pseudo, we have discussed this application, that this acceleration required would be g tan theta. I hope you remember this because we have already discussed this in the same session. So this is a equals to g tan theta is required, and I have been given one more factor, it's a sine theta, that is equals to 1 by L. So let's change our notations based on the options given. So what I can do is that I am having sine theta according to the data. This is sine theta, so this must be the 1, this must be the L. Let's assume that this is x. So according to the Pythagoras, I can write like this, it's a 1 square plus x square is equals to L square, and from this x square should be equals to L square minus 1. So this could be written as under root of L square minus 1. Now I am having a is equals to g tan theta. So this is g multiplied by tan theta. Tan theta would be equals to 1 by root of L square minus 1. So this should be g divided by root of L square minus 1, and this should be the acceleration. I hope this is clear. Is it clear? What was your answer? What was it? Was it same? Was it? Great. Now what was the action force? What was the reaction force between block and wedge? Yes, it was mg by cos theta. Please do remember this. Do not make a mistake to write it down, mg cos theta. Let's look at the next question. It says that according to this, a horizontal force of 10 Newton is necessary to just hold a block stationary against a wall. The coefficient of friction between the block and the wall, it is 0.2. What I need to find out? I need to find out the weight of the block. Okay, great. So this is mass m, this would be probably the mg, and this would be the friction. So if I am doing that F is equals to mg, then block is not going to move anywhere, not on horizontal, not on vertical. So we can have F less than or equals to mu s into n. So this is equals to mg should be less than or equals to mu s multiplied by F, that F applied is the 10. So this is equals to m multiplied by 10, that should be equals to less than or equals to mu s, it's a 2 by 10 multiplied by 10, this 10 has gone, This 10 10 is gone, and what I can have is what I can have is that it is the m equals to, this is the f should be equals to, this is equals to, this is 2 by 10. I hope this is clear. Is it clear? Yes. And from this you can have a weight too. That weight could be equals to m into g. This is equals to 2 by 10 multiplied by 10. This is equals to 2 Newton. I hope you got the same answer. Yes, even this is the question that we have done in our questions based on the frictions only. Yes, in that time in that time we have been used to find out the value of the force F, so that this block cannot moving downward direction. Is it clear? Great. Let's work for the next question. It says that a box is lying on an inclined plane, and if the block slides when the angle of inclination is 60 degree, great, then the coefficient of static friction of the blocks at the box and the plane. So so do you know what angle of friction is? Do you know what angle of friction is? It is that angle, let's suppose this is angle theta. It is that angle at which this box starts sliding down. I hope this is clear. And this could be given as mu s is equals to tan theta. This is angle of friction. Yes. Now go through the data one more time. It says that if the box slides when the angle of inclination is 60 degree, if the box slides when the angle of inclination is 60 degree, I need to find out the coefficient of static friction. So this is equals to tan 60 degree. What is it? What is it? Yes, it's a tan 60. It's a root 3, and root 3 could be written as 1.732. This is the value of mu. Yes, but for this you must understand the concept of angle of friction. I hope this is clear. This is, let's say, box M. Is it clear? Is it any issue, any confusion? Do you have any confusion in this? Anything? No? Great. Ready for the next question? Ready? Let's look at this. It says that a nucleus emits alpha particle. It says a nucleus emits alpha particle with velocity v. Find out the recoil velocity of nucleus. Okay, so a nucleus is there, and initially it was at rest. Now from this, let's suppose this nucleus having atomic number as a z and atomic mass as a. It is initially at rest, and as it is going to be disintegrated such that alpha particle is going to emit from this, and if alpha is going to emit from this, it is just the 2He4, and its mass would be equals to x, or I should say element would be a change, it's an a minus 4. What do I want? I want the recoil velocity of the nucleus. Now how should I do this? What I understood is that momentum of the system is being conserved. It says that momentum of the system is being conserved, so initial momentum should be equals to final momentum. Initially the system is at rest. Now it would be an m1 v1 plus m2 v2 if I just interested in the magnitude. So this could be written as m1 v1 should be equals to m2 v2. Let's assume that this is nucleus and this is alpha particle. So if this is nucleus, the mass of the remaining nuclei is a minus 4 multiplied by v1, and mass of the alpha particle, it's a 4 into v2. Now v2 is given as a v, so I take this as a 4 into v. This is equals to a minus 4 multiplied by v1. from this it's a v1 that should be equals to 4 upon a minus 4 multiplied by v. I hope this is clear. Got this? Do you got this? Are you sure? Are you? Great. So so this is just the momentum conservation. Even this question has been asked in AIPMT twice. Yes, because even the same concept can be applied according to the atom and nucleus. It is the part of the modern physics in class number 12 at in the physics. So even that syllabus or even that content can be covered using this. So you must focus on this. Now let's look at the next question. What does it say? It says that a block of weight 200 Newton is pulled along a rough horizontal surface at constant speed by a force of 100 Newton acting at an angle of 30 degree above the horizontal. The coefficient of kinetic friction between the block and the surface. So let's try to make a situation. It could be a block of weight 200 Newton. So mass would be 20 kg and this would be the mg, which is 200 Newton. It says that a block of weight 200 Newton is pulled along a rough horizontal. This is horizontal and rough at constant speed by a force of 100 Newton at an angle of 30 degree above horizontal. Yes, this is the F. This is the 30 degree above horizontal. The coefficient of kinetic friction between the block and the surface, this is required. So let's have a diagram of this. It's an F cos theta. Here it would be a normal and it would be an F sin theta. So what I understand is as it is moving in the positive x direction and they want a kinetic friction, that means this F cos theta must be greater than friction. Then this is possible. Now what is friction? It would be mu k multiplied by n, and that would be equals to n. Now let's look at this n plus F sin theta will make an mg. So n would be equals to mg minus F sin theta. This is equals to friction. So this if I write this, it's an F cos theta should be greater than F. And if I put up the value of cos theta, let's just take a minimum value as an equal to, then I can have it's a mu k into mg minus of mu k multiplied by F sin theta. I hope this is clear. Yes. Now this force is given as 100 Newton and this angle is given as a 30 degree. So this is 100 into cos 30, which should be a root 3 by 2. That should be equals to mu k multiplied by mg, which is 200 minus mu k is required F, it's an 100 into sin 30, it's an half. So this is equals to mu k multiplied by 200 minus this is 50. So this is 200 minus of 50, and that should be is equals to 50 into root of 3. So this is mu k multiplied by 200 minus 50, which should be an 150, and this is equals to 50 root 3. So mu k should be 50 by 150 multiplied by root 3. This is 53. So mu could be this is 3, this is root 3, it could be a 1 by root 3, which is 1 divided by root 3, it's a 1.732. I hope this is clear. Yes, it is less than somehow 0.6 or a certain less than 0.6. Yes, got this? Have you got this? Are you sure? Great. So ready for the next question? You are doing good, pretty good. Yes, we are just going to cover all the questions that have been asked or that have been repeatedly asked in the various competitive examinations. Yes, as it is a very important unit. Questions are questions are of different category, and according to the numbers as well, this are the many questions. Yes, So let's work on it. Be positive, and we are going to solve each and every question that has been asked. Let's have a look. It says that a particle is projected up along a rough inclined plane of inclination 45 degree with the horizontal. It says if the coefficient of friction, if the coefficient of friction is zero point 0.5, then the retardation is yes. So the situation is something like this, that this is theta, particle is projected up, it is going to be mo moving in the upward direction. This inclination is 45 degree with the horizontal, and this is moving in the upward direction. As it is moving in the upward direction, this is the friction. Yes, so if this is moving in the upward direction, this would be moving in, acting on the downward direction. This is mg sine theta, and this is friction. So this f could be written as, this f could be written as, it's an mg sine theta plus plus mu into mg cos theta, but this f could be written as m into a, which should be an mg sine theta plus plus mu into m into g into cos theta. So this m has gone, and this could be written as, this could be written as a should be equals to g sine theta plus mu into g cos theta. This sine theta, this is 45, so this is g into sine 45, it's a 1 by root 2 plus mu is the 0 0.5, it's in half, multiplied by g into cos 45, it's a 1 by root 2. I hope this is clear. So this would be the answer of acceleration. I hope this is clear. Was it clear? Will you be able to do this? Are you sure? Are you sure? Can you do this? Great. Ready for the next question? Are you? Are you ready? Let's have a look. This is very important question. Very important question. First, let's have a look, and then I will let you know that what is the concept behind it. Let's understand that they says that an insect crawls up a hemispherical surface as shown in the figure, and the coefficient of friction between the insect and the surface, even this is given, which is equals to 1 by 3. If the line joining the center of the hemispherical surface to the insect makes an angle with the vertical, the maximum possible value is given by. So how could I calculate the maximum possible value of mu, coefficient of static friction? So what I understood is, the situation is something like this. Let's assume this is hemisphere, and if this is taken as a reference, if when insect is over here, when insect is over here, it is going to slip down, and once it is going to slip down, once it is going to slip down, that means this is the maximum possible, this angle is given as theta. So this has been drawn over here. Yes, so now let's have all the forces, that this could be written as mg. If this is mg, this is theta, so this should be mg cos theta, this should be the mg cos theta, and in this direction, in this direction I should write, this is mg sine theta, and on this direction, on this direction, it's a friction. I hope this is clear. This is clear, is it? So what I can write is, it's an n should be is equals to, this is the normal, this n should be written as mg cos theta, and friction could be written as mg sine theta. Let's assume this is relation number 1, this is relation number 2. If I took 2 divided by 1, it would be an f divided by n, this mg gone, and this is equals to tan theta. So if I solve this, it's an f by n, that should be equals to tan theta, f could be written as mu s into n divided by n. That should be is equals to tan theta. So this n has gone, this n and n has gone, and that tan theta could be represented as mu s. I hope this is clear. Is it clear? Is it? Is this tan theta could be written as mu into s? Is it clear? Got it? Are you sure? Are you? Great. So this is one of the concept through which we can solve this. Now another approach, that this was the hemisphere, yes, and this was the center of the hemisphere. Let's suppose insect can crawl up to this height. Let's suppose this is alpha. So if I apply angle of friction, if I apply a concept of angle of friction, let's assume at point A, then I can directly have mu is equals to tan alpha. Yes. What angle of friction says? It says that let's suppose you are rising a certain height, and at that height you are not going to sustain. That means you are going to slip down. That angle is known as the angle of friction, and it is the same. So this is the methodology, and this is the pure logic. Yes. So this has been proved using the mathematics, and this has been proved using the theoretical concept. I hope this is clear. Is it clear? Is it? So does it clear? Now I want to add two more questions to this. Now let's have a look to those questions. So now suppose they have given, this was the given data, that the this was the hemisphere, and this was the center. Let's suppose this is the height at which it is going to be slipped down. Now if I take this as a reference, the question will be, find out first height and second horizontal distance. Find out first height and second horizontal distance that 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 an insect covers before it slips down. So now how could I do this? Tell me how could I do this? This is alpha, that is given. So now what I understood is that, let's suppose this is the radius of hemisphere. If this is radius, even this complete would be a radius. I am interested in this y. So this could be written as r cos alpha. Is it clear? This could be written as r cos alpha. So what I can write, it's an r cos alpha plus y, that should be is equals to r. So this y could be written as r minus r cos alpha, and this is the height h. This is the height h through which it has covered. It's h is equals to r into bracket, 1 minus cos alpha. Is it clear? So this is the vertical distance that insect is able to cover. Now let's talk about the horizontal displacement. This was the situation. This is alpha, this is r cos alpha, this is r. So this is the r sine alpha. So x could be written as r sine alpha. This is the vertical displacement and this is the horizontal displacement. If you are getting confused, let me replace this with the displacement. Now is it clear? Is it clear? Are you sure? Are you? So this is very good question. This is very logical question. You must keep this in your mind because this is the question that has been asked so many times in different formats in different examinations. So please do remember this. This is very good question. I hope this is clear. So shall we move to the next question? Shall we? Shall we move? Let's have a look to the next question. What does it says? It says that a body of mass 5 kg starts from the origin with an initial velocity of u is equals to 30 I plus 40 j meter per second. If a constant force F, that is 6I minus 5j, is acting on it, Newton's acts on the body, then the time in which the y component of the velocity becomes 0. Okay, you want to find out the time in which y component of the velocity will be 0. So how could I do this? How could I? So what I understood is that force is given, and this force is equals to 6I cap minus 5j cap. Even the mass of an object is given, which is equals to 5 kg. So from this acceleration could be calculated. This acceleration would be equals to, it's an F divided by m, which could be written as 6 by 5 I cap minus 5 by 5, which is equals to 1 j cap. I hope this is clear. Is it clear? Now if I compare this acceleration, this is 6 by 5 I cap minus 1 j cap. If I compare this with axi minus ayj, that means acceleration in y direction is the minus of 1 in j cap. I hope this is clear. And the velocity is given as u is equals to 30 I cap plus 40 j cap. So this is ux I cap plus uy j cap. So this uy initial velocity in y direction, it is 40. Acceleration in y cap, it would be a minus of 1 into j. Now I can have a relation that vy is equals to uy minus of a into t. This should be 0 according to the data. This should be the 0 according to the data, the time at which y component of the velocity becomes 0. This was the question. So this is 40 minus of 1 into t, and that would be equals to 0. So this is 40 is equals to 1 into t, and this time required would be a 40 seconds. I hope this is clear. Is it clear? What was your answer? Was it same? Was it same? Great. So ready for the next question? Ready? Are you sure? Let's have a look. It says that two blocks of mass m1, which is of 20 kg, this is m1, and m2, this is of 12 kg, are connected by a metal rod of mass. Even this metal rod is having a mass which is of 8 kg. The system is pulled vertically up by applying a force of 480, it's a 480 Newton as shown. The tension at the midpoint of the rod. Now how should I do this? What I need to find out, I need to find out the tension at the midpoint of the rod. So if I understood fully, then I could replace this is m1, this is, they want it at a midpoint, so this is 4 kg we can assume, and even we can assume this as a 4 kg. So this could be written as m2 and this could be written as m3. This m1, this m1 is same, it's a 20. This m2, it's a 4, and this m2, it's a 12. I hope this is clear. This is clear. Is it? Is it? Or shall I redraw this? Shall I? Let's have a look. What I was about to do is that this is the first block, this is the second, third, and fourth. This is the m1, which is of 20 kg. This is the 4 kg. This is the 4 kg, and this is the 12 kg. Now, at this point, at this point, you are requiring a tension. So you required a tension over here. I hope this is clear. Is it clear? Are you? Are you clear with this? Great. And this is being pulled by 480 Newton. So what I need to do is first and foremost task is to calculate the acceleration of the system. So to get the acceleration, what I can do is that this is the force which is of 480 Newton. Now what all forces are acting in the downward direction? This is the 20 into g. Yes, this is the 8 into g, and one more, it's a 12 into g. So this is 12 plus 8, 20 plus 20, this is 40 g. So this could be written as 480 Newton minus 12 plus 8, 20, 20, 20, 40. It's 40 into g. That should be is equals to total mass. Total mass, it's a 20 kg into acceleration. So this is 480 minus of 40 into g, which should be in 400, should be is equals to 20 into acceleration. So this is 480, this is 400, which should be an 80. So this could be written as 80 should be equals to 20 into acceleration. Acceleration would be equals to 80 by 20, which should be 4 meter per second square. I hope this is clear. Was it clear? Now what I need to find out, I need to find out at point T. Let's suppose this was the point that at which I required tension. This was 4 kg, this was 12 kg, and this system is moving in the upward direction. So what I need to write, it's a T minus mg is equals to m into a. So this is T minus 4 plus 12, it's a 16 into g, that should be is equals to 16 into a, and acceleration was 4. So this is equals to T is equals to 16 4s are 64 plus 16 into g, which should be an 160. So it's a 160 plus 60, 160 plus 60, it's 220 plus 4, it's a 220 plus 4. So that should be is equals to 224 Newton. I hope this is clear. Was it clear? Was it clear? Are you sure? Are you? Great. I hope this is clear. Got it? Great. Let's work for the next question. It says that according to the question, a satellite is moving with a velocity v in a force free space, collects stationary interplanetary dust particle at a rate of dm by dt, which should be equals to alpha into v, where m is the mass at that instance. The instantaneous acceleration of the system of the satellite, sorry. So what I could do is I can write that f should be is equals to mass into acceleration, which could be also written as v into dm by dt. Yes, as I understand that this dm by dt is equals to alpha into v, so this is equals to v into alpha into v. So this is equals to minus of alpha into v square. Yes, now what is a, that is equals to minus of alpha into v square divided by m. This would be the answer. Got it? Got it? Is it clear? Is it? Are you sure? Are you sure? Great. Ready for the next question? Let's have a look. It says that it says that water is flowing at a speed of trough a horizontal tube of cross sectional area 10 to the power minus of 2, and you are trying to stop the flow by your palm. Okay, assuming that the water stops immediately after hitting the palm, the minimum force that you must exert should be. Okay, so what I can do is that is equals to F is equals to rho multiplied by A multiplied by V square. Yes, fit the data and get the answer. I'm sure that you will get this. Now let's look at the last question. This is the last question of this unit and this lecture as well. Let's do it quickly. It says that a body of mass 10 kg, a body of mass 10 kg is acted upon by a given by equation, that is F is equals to 3t square minus 30 Newton. The initial velocity of the body, that is the u, is given, that is equals to 10 meter per second. The velocity of the body after 5 seconds, so v at t equals to 5, this is required. So how will you do this? What I understood is that F could be written as m into a. This force, it's a 3t square minus of 30. This is equals to mass 10 into acceleration a. So this a could be written as this is equals to 3t square minus of 30 divided by 10. I hope this is clear. Now this is could be replaced as, this is a is equals to dv by dt, and while I say a is equals to dv by dt, that could be it's a 3t square minus of 30 divided by 10. Is it clear? Is it? Great. So now it's a dv, that should be is equals to 3t square minus of 30 divided by 10 into dt. Is it clear? So now if I integrate this, here it's a u to v. This is equals from t equals to 0 to t equals to 5. This will give me a v minus u, and this 1 by 10 would be on a side. It's a 3t cube by 3 minus 30 into t. I hope this is clear. Now put up the value and get the required answer. I hope this is clear. Is it clear? Great. So let's wind it up this session over here. This was all about the laws of motion. Yes, we have completed this unit over here. Please keep this unit in practice for at least 2 to 3 months. You need to solve the questions based on this topics for approximately 3 months, and at least 10 to 20 question each day. Then only then you can have a little confidence on the laws of motion. I hope this is clear. Please do it, because when and when you are going to have a command over it, physics of class 11 and class 12 would be much easier for you guys. I hope this is clear. Please do it. This is the requirement of physics. I hope you understand. So thank you, have a good day, take care, bye bye.